all of your bills that have these interval meters. You lay out all the information. It's a little hard to see here, but if you can look carefully, you'll see there's a green line on the bottom that shows weather. Because as I've been talking to you, weather is quite important. And then you have the brown line, which is, you have the blue line, which is what you actually use, and then you have the brown line, which is what our software predicted you should use based on your historical usage, based on a bunch of algorithms that apply to the data. When the blue line exceeds the brown line, you've used more energy than you should have. When the brown line exceeds the blue line, you've been more energy efficient. This is not to taunt you, but if you look here, you'll see, if I look at this building, I see two things. Clearly, I see on the weekends that there's more usage going on than should be anticipated. That would imply to me that maybe someone's leaving some equipment on over the weekends, or maybe someone's coming in and using the buildings for, maybe it's legitimate use, maybe it isn't. So, and then I see this a few times during the week, especially this one instance over here, on the 6th day, where you see that blue line, that blue thing sort of blip up. Something happened there. So even if I'm looking at this in well after the fact, a month after the information was when this happened, I'd go and I'd say, let's find out what's happening on the weekends, and let's see if there was some particular event on that day, and then let's see how we might want to be more, tighten up our rules of how space is used and how we report it. So I'm not expecting that everyone is going to be super diligent or change their habits totally, but I think these give you reasonable indications of what's happening that will help you manage your buildings a little bit more efficiently. So here's a little bit more clearly highlighted where the green is circled, where the brown, which is the predictive part, exceeds what actually happened, you're doing better. And where the blue exceeds the brown, you're actually doing worse. So again, like here, this clearly, in this event, 3 days in a row, you had this aberrant high demand. And in fact, if you look at these numbers, that third day in the circle, in the center of the circle, exceeds all the other days. So it means not only had an aberrant demand, but it actually peaked your demand even higher. So if you didn't have that one instance in that one day, your bill would have been materially lower, or lower at least. All make sense? Mm-hmm. So another thing you do with the data is you try to shape it, sort of like what I just illustrated to you, is peak shaving. So peak shaving is trying to look at, it's sort of like my example about the warehouse, where you used it all. Ideally, you want to use your energy, and I'll show you a good slide of that. And the most ideal, it's like a pipe. You want to keep the pipe full and use it all the time because you're paying for the pipe to be there. You want to get the maximum usage of the pipe. You don't want to have just drips of water, drops of water going through the pipe. Looking at where you have these aberrant peaks, like what I showed you before on the previous slide, or as you can see here, what's been sort of boxed in here, can have a material effect. It isn't like you're going to catch it all because it happens in real time, but knowing that it happens can make you more aware of how to look at what the causes are. It's not simple, but it's something that you should try to get your building engineers to start to focus on, be a topic of conversation. An extreme story. I was once walking.